Chemistry, we're about to begin a few lessons that take a deeper dive into the structure of the atom. This one is called orbitals and subshells. So in earlier units we used the Bohr model of the atom, which contains simple circular energy levels called orbitals. Now we are going to learn a more advanced model of atomic energy levels in which each orbital is divided into subshells. The subshells are labeled S, P, D, F, and have shapes described by mathematical equations. The S, P, D, F subshells must occur in that order. For example, the fourth row orbital of the periodic table has 4 subshells labeled 4s, 4p, 4d, and 4f. We have said that the period row represents the number of orbitals. This number is formally called a principal quantum number. The type of subshells that a row has depends on the row in the periodic table as follows. The first row has only an S subshell, and the elements in that would be labeled to be in the 1s subshell. The second row has both an S and a P, and the elements in that row would be labeled either 2s or 2p. The third row has an S, a P, and a D. The fourth row has an S, P, D, and F. The fifth row also has an S, P, D, and F subshell. Sixth row S, P, D, and seventh S, which we'll never deal with. So each row of the periodic table must fill its subshell in the order S, P, D, F. So the first row elements hydrogen and helium place an electron in the 1s subshell. After the first row, all S subshell elements are alkali or alkaline earth metals in the first 2 columns. Those are the ones you see in gray. The second row has a 2s, which is where lithium and beryllium reside, and they place 2 electrons in the 2s subshell first. When the S subshell is filled, the next 6 elements, boron, carbon, nitrogen, oxygen, fluorine, and neon, place electrons in the 2p subshell, which has a slightly higher energy level than the S subshell. So that's the difference between the subshells. The 2p is a little bit higher energy than the 2s. Not as high as the 3s. The 2p is not as high as the 3s, but it's higher than the 2s. The third row starts with sodium and magnesium that go in the 3s subshell. And then you have aluminum, silicon, phosphorus, sulfur, chlorine, and argon place electrons in the 3p subshell. Next comes the third orbital D subshell. Since the P subshell must come before the D, the 3D is placed in the fourth row. So think about it. The order has to be S, P, D, F. So why don't we call what we see as the 3D, why don't we call that the 4D since it's in the fourth row? That would make the order of the fourth row to go 4S, 4D. That's illegal. D cannot come before P. It has to be S, P, D. Therefore, that D subshell, the 3D, must belong to the third row because the third row has already had the P subshell. So again, 4S, 4D, 4P is illegal because D would come before P. Therefore, even though the 3D is in the fourth row, it is still called the 3D subshell. So D subshells, transition metals, are always placed 1 row below their row number. Okay? So subshells, the D subshells represent the transition metals. Okay, the fourth row. Potassium and calcium electrons go in the S subshell, as you see there on the left. Gallium, germanium, arsenic, selenium, bromine, and krypton, they go in the 4p subshell. Next comes the 4 orbital D subshell. That's placed in the 5th row. Again, that D subshell, the 4D, cannot be the 5D. Otherwise, the 5th row would go 5s, 5D, 5p, and that's illegal. D cannot come before P. So that D has to belong to the fourth row, or the fourth principal quantum number. 4s, 4p, 4d. The fourth orbital has an F subshell placed in the sixth row. Okay, now it starts to get a little deep, but we rarely deal with this one. So down in the fifth row is the 4f subshell. And why is that? Because the 4d must come before the 4f. That cannot be the 5f subshell or the 6f subshell. It has to be the 4f subshell. So the 4s subshell is 2 rows below the fourth row. It appears in the sixth row. So that's all you really have to remember. Okay, the fifth row, we have the 5s. Then we have to skip over the 4d to the 5p. Now we go to the 5d, 1 row below, and it's down in the sixth row. And now the 5f subshell is down in the seventh row. It's 2 rows below its principal quantum number. So the 5f subshell is placed in the seventh row. All right, and that takes care of this lesson and how you're going to designate the different subshells, which represent slightly different energy levels.